Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture, we are going to implement Deep Q-Learning in TensorFlow for CartPole. This simple example is going to let us at least observe Deep Q-Learning in action in a reasonable amount of time. If you don't want to try to code this yourself, although I highly recommend you do, the relevant file in the course repo is dqn_tf.py in the subfolder CartPole. At the top, we have all of our usual imports. After that, we have the hidden layer class. Notice how we are keeping track of the params as an instance variable, whereas we didn't do this before with TensorFlow. Typically, we don't need to since the TensorFlow optimizer takes care of this. However, we need to have a list of all the params since we're going to be writing a function to copy the params from one network to another. Next, we have the dqn class. In the constructor, we take in the number of inputs d, the number of output actions k, the hidden layer sizes, gamma, the experience replay buffer size, which we call max experiences, the number of experiences to collect, before training, which we call min experiences, and batch size, which is the number of samples we are going to use to train. The next step is to create all the layers. After that, we collect all the params in the network, since as we discussed, this will be useful for copying the main network to the target network. Next, we declare the input and target placeholders. Next, we calculate the output and the cost and the optimizer. This should all look familiar to you. Again, I recommend testing out different hyperparameters and different optimizers. Next, we create the replay memory. This is one way of doing it, but I'll show you another way later. We also need to save some of the inputs as instance variables for later use. Next, we have setSession, which you've seen before, and you know why we're using it. Next, we have the copyFrom function. This will copy all the params from the input network to itself. This is why we wanted to keep track of all the params earlier, because now we need to loop through them, get their values, and assign them to the corresponding param in the other network. Notice these are all ops, so we need to run them inside a session. Next, we have the predict function, which you've seen before. And next, we have the train function. This you have not seen before. First, if we haven't collected enough experience, we just return without doing anything. Otherwise, we select a set of random indexes equal to the batch size. Next, we index the experience dictionaries to get the states, actions, rewards, and next states. We then use these next states to calculate the Q targets. Notice the use of the target network here. This also explains why we needed to pass in gamma earlier. Finally, we call the train op with this data. In a later lecture, you'll see a more compact way of sampling the batches, but it's less straightforward to parse. Next, we have the addExperience function. This just adds the for tuple of the state, action, and reward, and next state to the experience list. Finally, we have the sampleAction function, which is the same as before. Next, we have the play1 function. This is almost the same as before with some minor changes. In the section of the code where we update the model, we also add an experience. The train function now only takes in the target network as an argument, since all the data is stored in its experience buffer. And we also use the argument copy period to tell us how often to copy the main network to the target network. Next, we have the main section. This is largely the same as before, except of course now we are creating a dqn, which has some different parameters. So let's run this and see what we get.